by Kyle Bennett ad Namid Sense 160 by 600_orange. Back in the 1950s, an American professor called Charles Hapgood proposed that the Earth's crust slides as a whole over the fluid layers below once every 40,000 years or so, causing the position of the geographic poles to wander, i.e. polar wandering. He thought this explained the pattern of ice ages and many other mysteries of this strange planet's history. But like many good ideas, most geologists have chosen to ignore Hapgood's theory of Earth crust displacement, and never address its key arguments. Instead he is ridiculed, and the idea is widely claimed to be pseudoscience, catastrophism, Atlantis hunting, 2012 millenarianism, or even occult. It has been marginalized, and therefore geologists are afraid to investigate it for fear of being ridiculed and ostracized by their colleagues. It has been successfully branded as an alternative subject which has no place within academia. But where did the original idea come from? Charles Hapgood, Hugh Auchincloss Brown, in the 1940s, or, as some dishonest sources claim, a psychic prophet. A little-known fact, which has escaped the attention of probably all commentators on polar wandering, is that the theory was first developed by Sir John Evans, shown here on the picture to the left, the president of Britain's Geological Society. He was also a fellow and treasurer of the Royal Society, the most prestigious scientific society in Britain, if not the whole world. It boasted Charles Darwin, Charles Lyell and many other greats among its fellows during Evans' time as its treasurer. And Evans was close friends with Lyell, who is usually considered the father of geology. Way back in 1866, Evans published a paper titled On a Possible Geological Cause of Changes in the Position of the Axis of the Earth's Crust. This set out almost exactly the same theory as Hapgood developed almost a century later. Just like Hapgood, he believed the most recent ice ages in Britain and North America could be explained by crust displacements, claiming that these lands were much nearer the North Pole in those times. A colleague of Evans, called Sir Henry James, was convinced that evidence of extreme climate change found in the geological record, including fossils proving that the Arctic was once tropical, could only be explained by polar wandering, with displacements of the whole Earth's crust being the suggested cause. As James Geikie described in The Great Ice Age 1887, Mr. Evans has ingeniously sought to account for the remains of large trees that are found in Greenland, and for the traces of glacial cold in this country, i.e. Britain, by considering whether it might not be possible that the external crust or shell of the globe had actually slid round its fluid or semi-fluid nucleus, so as to bring the same areas of the external surface under very different conditions. Thus, it was suggested that lands, which at one time basked under a tropical sun, might, in the slow course of ages, be shifted to some more northern region, while countries which had for long years been sealed up in the ice of the Arctic Circle might eventually slide down into tropical latitudes. Evans came to this opinion after studying the work of his colleague, Sir Henry James, who had come to the conclusion that the only possible explanation for those tropical climates in the Arctic was polar wandering. As Evans explained in 1866, Sir Henry James, writing to the Athenaeum newspaper in 1860, stated that he had long since arrived at the conclusion that there was no possible explanation of some of the geological phenomena testifying to the climate at certain spots having greatly varied at different periods, without the supposition of constant changes in the position of the axis of the Earth's rotation. Evans was highly convinced by this view, and went on to propose his theory of crust displacement, which would allow the parts of the Earth's surface to back and forth between the tropical and polar regions over the ages. This crust, from various causes, is liable to changes disturbing its equilibrium. It becomes apparent that such disturbances may lead, if not to a change in the position of the general axis of the globe, yet at all events to a change in the relative positions of the solid crust and the fluid nucleus, and in consequence to a change in the axis of rotation, so far as the former the crust is concerned. He proposed that rising mountain ranges may cause a gravitational imbalance in the crust, which would then act to slide the crust over the molten rock below, through the action of centrifugal force upon them. He then discussed how large ice caps, placed off-center of the poles, would have a similar unbalancing effect. So here was Hapgood's theory on the cause of Earth crust displacements, being seriously discussed a century earlier by the president of the Geological Society. And the arguments he used are still relevant today. He even built a complicated model which he presented to the Fellows of the Royal Society. It demonstrated, using weighted adjustable screws attached to a wheel, representing a section of the crust, how an imbalance in the spinning crust would cause it to rotate. The subject was then seriously discussed a decade later at a symposium of the Geological Society, on February 21, 1877. Hapgood and James Campbell detailed in The Path of the Pole how a crust displacement would cause mountain building and rift valleys because of the squashed shape of the globe, which causes the crust to be compressed when moved towards the poles, and stretched when moved towards the equatorial bulge. As Evans explained in 1866, a displacement could cause elevations and depressions of the land as well as other effects, slaty cleavage, dislocations, and undulations in the various strata, results which might be expected from the crust of the Earth having to assume a new external form, if caused to revolve on a new axis. But the most insightful observation by Evans was on the climatic evidence for polar wandering. Back in the Victorian era, more and more evidence was turning up that the Arctic was tropical not too long ago. This has been proved beyond doubt in recent years by modern explorations in this ocean. It was tropical in the Eocene about 50 million years ago, and was subtropical a mere 3 million years ago. But modern geologists simply refuse to even consider the possibility that the Arctic was actually near the equator in those times. And they ridicule those who consider it, calling them cranks, conspiracy theorists, etc., etc. So what did Evans say without in the slightest degree undervaluing other causes which may lead to climatal changes? I think that possibly we may have here a vera causa such as would account for extreme variations from a tropical to an Arctic temperature at the same spot, in a simpler and more satisfactory manner than any other hypothesis. And it is now known, as modern exploration has discovered, that the Arctic flipped between a glacial and almost tropical climate a number of times during the Eocene, as well as later on. So, what does that suggest? Evans was even more confident that his theory was correct when discussing the remains of tropical plants found in the Arctic. The former existence of cold in what are now warm latitudes might, and probably did in part, arise from other causes than a change in the axis of rotation, but no other hypothesis can well account for the existence of traces of an almost tropical vegetation within the Arctic Circle. They seem to afford conclusive evidence of a change in the position of the pole since the period at which they grew, as such vegetation must be considered impossible in so high a latitude. This is the conclusion that Hapgood came to, and which I confirm in my upcoming book, Polar Wandering and the Cycle of Ages, where I look at how modern research has more than supported the hypothesis of rapid polar wandering. Should be available to buy from July 2011. Please visit my blog for details. Unfortunately, most young people who are curious about the theory, and have an intuitive sense that it could be correct, start by reading about it on the internet. Here they are bombarded with disinformation and nonsense, and spend hours trying to find good information. They often then conclude that the whole subject is crazy, and lose interest. I don't blame them. There are precious few quality, genuine sites discussing this subject. Nearly all of the internet commentators simply recycle well-known material and don't do their own research. This explains why the crucial role of Sir John Evans has been forgotten, even by die-hard pole shift anoraks. The foresight of Evans is truly amazing, and helps put into a proper historical context the oft-quoted remark of Albert Einstein regarding Hapgood's theory of Earth crust displacement. I find your arguments very impressive and have the impression that your hypothesis is correct. One can hardly doubt that significant shifts of the crust of the Earth have taken place repeatedly and within a short time. But in fact we must go further back in time, and give recognition to another great man whose contribution has been forgotten. He was a Dane called Frederick Alexander Gottlieb Clay. He published an astonishing book, Le Déluge, in 1847, where he claimed the last ice age was ended by a déplacement au lax de globe. Science has advanced greatly over the years, and has vindicated Clay, providing solid evidence to support his claims. Despite this, it is still ignored. But logic and reason are timeless, and cannot be ignored indefinitely. So how long can the scientific establishment ignore it for? Another 100 years? Probably not. The key issue is this. Although the current knowledge of polar wandering is still fragmentary, the core theory and its empirical proof is very, very strong. So if there were truly a level playing field in the battle of ideas, with academics freely debating the different theories without prejudice or fear of losing their jobs or their funding, if the media gave a fair hearing to it, without marginalizing and ridiculing its proponents, in this situation polar wandering would wipe the floor with all the alternative theories on the cause of climatic changeover of the ages. It would quickly become the orthodoxy, the dominant theory, the new paradigm. It is only a matter of time before geologists and their paymasters choose to openly and freely investigate it. Thanks for reading. Copyright Kyle Bennett, http://kylebennett.blog.co.uk. Polar Wandering and the Cycle of Ages by Kyle Bennett. This book will be available to buy from July 2011. Part 2 by Kyle Bennett. This article is based on the introduction to Kyle Bennett's Polar Wandering and the Cycle of Ages, soon available. Please see http://kylebennett.blog.co.uk for details and for more articles on this subject. Journeying into the frozen wastes of the far north, 19th-century explorers found the remains of strange animals, buried under the permafrost. One such explorer was the German geologist Baron von Toll, who traveled through Siberia and to the Arctic islands on behalf of the Russian Academy of Sciences, bringing back the bones of mammoths and saber-toothed cats from the most northerly of island archipelagos. These finds astonished the Victorian public, leading to wide speculation on how those antediluvian beasts could have survived up to there, and on how they died, before lying frozen solid for millennia. How could those inhospitable lands of the far north, the land of eternal ices, have supported abundant life in the not-too-distant past? Mainstream science has never answered this question. It remains an enigma, which few scientists even try and solve. Digging deeper into the rock strata of the Arctic islands and northern Siberia, an even more astonishing record was uncovered, dated to long before the time when mammoths roamed those lands. One early Arctic adventurer was Captain Nares, who set out on an ocean voyage in 1872, commissioned by the British government to explore its largely unknown waters. He found rich seams of coal on the Isle of Spitsbergen, deep within the Arctic Circle, revealing that great forests once grew there. Similarly, on the other side of the Earth, in Antarctica, the Byrd expedition of 1935 found coal beds within 200 miles of the South Pole, together with the fossils of warm-climate animals and plants, painting a picture of a balmy continent abundant with life. Those early expeditions to Antarctica showed it had enjoyed subtropical, and sometime even tropical, climates for millions of years, despite now being the coldest place in the world, the White Continent. While mammoths were being unearthed in the farthest north, equally bewildering discoveries were being made in Europe and North America. It was found that ice ages had recently visited these continents, covering them with mighty ice sheets. As they marched across land, these ice sheets scoured the rocks below and left a trail of debris for geologists to uncover. By piecing these clues together, they found that an immense ice sheet, in some places over a mile thick, had recently lain across much of North America. But the idea of ice ages was highly controversial, inducing a hostile response from the scientific establishment. Eventually, however, it became widely accepted due to the sheer weight of evidence supporting it. And the last ice age was accepted as being just one of many. Over the ages, ice sheets have left no land untouched, as glacial evidence is found all over the globe, even in the current tropics. So how could ice ages in the tropics and extreme warmth near the poles be explained? It didn't take long for many scientists to recognize that these paradoxes are two sides of a single coin, demanding a common explanation. The French naturalist Georges Cuvier 17,691,832 was one of the first to propose that some global event must have wiped out the mammoths of Siberia and caused them to freeze rapidly, allegedly before they even had time to decompose. Together with signs of great geological upheavals which he found in the rock strata, this led Cuvier to believe that life has been often disturbed on this earth by terrible events, calamities which, at their commencement, have perhaps moved and overturned to a great depth the entire outer crust of the globe. And a while later, in 1847, a Danish intellectual called Frederick Alexander Gottlieb Clay came up with a similar idea. He proposed in his book Le Déluge that at long intervals the whole surface of the Earth shifts in unison, causing a déplacement au l'axe du globe, a displacement of the Earth's spin axis, known today as a pole shift or polar wandering. According to Clay, warm-climate creatures found near the Arctic Ocean lived there when it was nowhere near the North Pole. The climate paradox, he believed, had been solved. The idea was later proposed in 1866 by Sir John Evans, who held prestigious positions as President of Britain's Geological Society and Treasurer of the Royal Society. He published a paper in the Proceedings of the Royal Society, titled On a Possible Cause of Changes in the Position of the Axis of the Earth's Crust. This paper sought to explain those strange discoveries of former warm climates near the Arctic. As James Geikie explained in The Great Ice Age 1887, Mr. Evans has ingeniously sought to account for the remains of large trees that are found in Greenland, and for the traces of glacial cold in this country, i.e. Britain, by considering whether it might not be possible that the external crust or shell of the globe had actually slid round its fluid or semi-fluid nucleus, so as to bring the same areas of the external surface under very different conditions. Thus, it was suggested that lands, which at one time basked under a tropical sun, might, in the slow course of ages, be shifted to some more northern region, while countries which had for long years been sealed up in the ice of the Arctic Circle might eventually slide down into tropical latitudes. In order to demonstrate his theory, Evans built a complicated model as suggested to him by Francis Galton Darwin, half-cousin of Charles Darwin, which he presented to the Fellows the Royal Society. A decade later, the subject of Evans' paper was seriously discussed by a member of the Geological Society, on February 21, 1877. So Klee's idea was widely debated by the Victorian scientific elite, a fact which all modern researchers on this subject have overlooked. See my guest page, http://www.scienceatouts.com. 16 Writer Kyle Bennett KL01.html, at the website of Arthur Ryan, author of Are We Worth Our Salt? For a more detailed discussion of Sir John Evans' work, please visit my blog, http://kylebennett.blog.co.uk. Despite this interest from the scientific establishment, it was many years before the idea of polar wandering was further explored. In the 1940s it was formulated into a more complete, modern theory by Hugh Auchincloss Brown, who was an electrical engineer and member of the American Association for the Advancement of Science. He was an amazing character, who wrote his book Cataclysms of the Earth when he was 90. Studying the strange layering of rock formations, one kind lying upon another, he claimed this was a visible record of successive pole shifts, with different types of rock having been formed in different latitudes. Rocks formed in tropical regions, containing the remains of tropical plants, are often overlain by rocks containing evidence of glaciation, which Brown claimed to mark the transformation from a life age into an ice age when lands were shifted into the frigid polar zones. Hugh A. Brown's ideas were later more fully developed by Charles Hapgood 190,482. He was a graduate of Harvard University, who later became a professor of the history of science at Keene State College in New Hampshire after serving in the Office of Strategic Studies, the progenitor of the CIA, as a civilian during World War II. He published his findings in 1958, in his book The Earth-Shifting Crust, followed 10 years later by an updated edition, titled As the Path of the Pole. His theory of Earth crust displacement proposed that the solid outer shell of the Earth, called the lithosphere, occasionally slides as a whole over the semi-liquid layers below, causing the poles to change their position on the Earth's surface. During a crust displacement, some parts of the Earth's surface would move towards the poles, and some towards the equator, while others would twist, remaining in similar latitudes but being rotated. So the cycle of ice ages is caused by successive crust displacements, moving continents in and out of the polar zones. He claimed the last ice age in North America ended when this continent moved southward by around 30 degrees latitude, while at the same time the once temperate Arctic Ocean and Siberia were moved up to the North Pole. So Hapgood believed he had solved the riddle of ice ages, which no other theory has even come close to solving. His theory of Earth crust displacement greatly interested the physicist Albert Einstein, who corresponded with Hapgood and provided a foreword to the first edition of The Earth-Shifting Crust, where he wrote that, his idea is original, of great simplicity, and, if it continues to prove itself, of great importance to everything that is related to the history of the Earth's surface. A great many empirical data indicate that at each point on the Earth's surface that has been carefully studied, many climatic changes have taken place, apparently quite suddenly. He has also set forth, cautiously and comprehensively, the extraordinarily rich material that supports his displacement theory. I think that this rather astonishing, even fascinating, idea deserves the serious attention of anyone who concerns himself with the theory of the Earth's development. To Einstein also told Hapgood, I find your arguments very impressive and have the impression that your hypothesis is correct. One can hardly doubt that significant shifts of the crust of the Earth have taken place repeatedly and within a short time. But for many years his theory did not receive the attention that Einstein said it deserved. Hapgood noted that crust displacements and continental drift were both considered by the German scientist Alfred Wegener in the early 20th century so as to explain the strange locations of fossil flora and fauna throughout the world. The poles and equator must, Wegener reasoned, have been in different locations than at present, so the idea that the Earth's crust could slide around seemed to provide the solution. However, major authorities in geology at the time, such as George Darwin and J.C. Maxwell, were opposed to the principle of displacements of the whole lithosphere, so it wasn't properly investigated for many decades. Meanwhile, as Hapgood explains, all the attention was paid to continental drift since changes in the positions of the poles relative to the continents now apparently had to be accepted. Perhaps continental drift would provide a less sensational way out than displacements of the whole lithosphere. It is quite true that the geomagnetic evidence very early indicated clearly that at the very least both things had happened. Nevertheless, such is the frailty of the human mind, scientific or not, that displacements of the lithosphere have been pushed into the background, and all the attention has been paid to continental drift. 3. The problem was that the geological evidence presented a mystery which the slow process of continental drift, the rearrangement of the continental plates, could not explain. Despite this unwillingness of most scientists to consider displacements of the entire lithosphere, the evidence supporting it grew steadily over the years, aided especially by the invention of the technique of radiocarbon dating. This technique allows scientists to measure the age of organic material, such as the bones of mammoths and other creatures found in the far north of Siberia. Many of these animals were found to have lived during the height of the last ice age, when large swathes of North America were covered by an immense ice sheet, leaving New York buried under over a mile of ice. Northern Siberia and the Arctic islands were home to roaming herds of herbivores, including mammoths, saber-toothed cats, horses, rhinoceroses, antelope and bison. The climate was temperate even in the far north of Siberia, as shown by radiocarbon-dated plant and tree remains. Meanwhile, the Arctic Ocean was largely ice-free. The remains of warm-climate species were found in a number of regions, including shells found on Baffin Island, Banks Islands, and even on Axel Heiberg Island, at 81 degrees north latitude. Also, core samples from the seafloor of the middle of the Arctic Ocean revealed that the Arctic had been much warmer during the last ice age than today, while similar evidence of temperate climates was uncovered in the Rossy area of Antarctica. It was evidence such as this which convinced Hapgood that the last ice age was in fact the last polar age. This conclusion was supported by the field of geomagnetism, which studies the position of the polar axis in the past by measuring the magnetic signal imprinted in rocks. It revealed that the geographical poles had changed their locations on the Earth's surface many, many times. Throughout the vast expanses of geological time, many pole positions had been recorded, with all the continents having been within the polar regions on numerous occasions, causing a succession of polar ages. According to Hapgood, these pole shifts happen roughly every 40,000 years, and are irregular both in timing and in direction, leading to a chaotic-looking, zigzagging pattern. Throughout the last few million years at least, the North Pole has remained in or near the Arctic Ocean, having zigzagged across this ocean numerous times. Hapgood estimated that the North Pole was previously in the Hudson Bay area of Canada, at 60 degrees north, 83 degrees west, where it remained from 50,000 to 17,000 years ago. This was a similar conclusion to Brown's, who called it the Hudson Bay Ice Age. Before then, the North Pole was in the Greenland Sea at 72 degrees north, 10 degrees east for 20,000 years, during the last major glaciation of Europe. Still earlier, it was near the Yukon District of Canada, at 63 degrees north, 135 degrees west. So Hapgood believed there have been 3 pole shifts in the last 100,000 years. The last crust displacement was estimated by Hapgood to have taken under 5,000 years to complete, ending no later than 12,000 years ago. This was shown by rapid changes in climate and the rapid meltdown of the Laurentide ice sheet in North America. This vast ice sheet took only a millennium or two to largely disappear, while Siberia and the Arctic rapidly froze. He concluded that the evidence points to a very rapid transit of the pole from its old to its new home. It must have completed its transition in a matter of centuries rather than millennia. Such a movement of the crust requires a force capable of sliding it over the semi-liquid layers below, within the asthenosphere, named from the Greek word for weakness. This layer begins at a depth of 30 to 40 miles below the Earth's surface, and continues down to a depth of 180 to 250 miles, below which intense pressure makes the deeper layers effectively solid. It has been discovered to be a soft, semi-liquid layer, due to the melting of rock which begins at this depth. Hapgood speculated that the outer layers of the Earth would slide over a weak layer found 100 miles below the surface. This layer of rock is called the waveguide layer, and was discovered by the Soviet geophysicist V. V. Belousov in the 1950s. Due to heat and pressure at this depth, chemical changes occur in the rock, reducing its strength. Satellite observations have recently found that this layer is very liquid, so that if a force great enough to move the crust had built up, this weak layer would give way, allowing the layers above to glide over it. Just like Sir John Evans a century earlier, Hapgood proposed that ice caps developing off-center of the poles could provide such a force to make the crust slide. The action of centrifugal forces caused by the spinning of the Earth would then act to push these misplaced ice caps towards the equator. If this force were large enough, it would cause a break, or shearing, at the weakest layer within the asthenosphere, resulting in the whole crust being displaced and the misplaced ice caps being moved away from the poles. Hapgood later had major doubts about this idea because the centrifugal force generated by misplaced ice caps would be great enough to shift the crust, even though they can be miles thick. He did, however, maintain that gravitational imbalances within the lithosphere must be the general cause of crust displacements. So the cause is still a mystery. But given that the causes of mountain building, volcanism, continental drift and various other phenomena are still mysteries, with theories concerning them being highly speculative, this state of affairs isn't unusual. The inner Earth remains a no man's land, and we are forced to scratch around on the surface for most of our clues. But luckily enough, more than enough clues have turned up over the years. As will be shown in Part 1, since Hapgood wrote The Path of the Pole, a vast body of evidence has amassed supporting his work, gathered from many fields of science. He had in fact gathered lots of new evidence himself, which he planned to include in a new edition of his book. This was never published, however, as he was killed one night in December, 1982. He was hit by a car. The edition he was about to publish when he died at the age of 78 did not alter the basic tenets of his theory, but would have presented some compelling new evidence. Since his death in 1982, the general idea of rapid polar wandering has gained momentum. Although Hapgood is never openly recognized, let alone Hugh A. Brown, or Clay, the idea is now proposed by eminent scientists as an explanation for many paradoxes of geological history. However, rapid to a geologist can easily mean a few million years, and few of them if any have considered the possibility of much faster shifts, largely because they violate the principles of uniformitarianism, a philosophy which proclaims that all geological processes occur slowly and gradually. Similarly, there is a complete refusal to consider whether rapid polar wandering has occurred in the more recent past, and whether it is the cause of ice ages. Recent research has provided an astonishing climatic history of the remote past, with rapid and dramatic changes in climate being identified by studies of rock formations throughout the globe. This pattern of climatic change continues right down from hundreds of millions of years ago to tens of millions of years ago. For example, the Arctic Ocean has witnessed astonishing changes throughout the ages. Tropical or subtropical life ages being followed by ice ages, with the Arctic moving back and forth between the tropics and the North Pole many times. The results from recent paleomagnetic research have supported the conclusion, revealing that all parts of the Earth's surface have changed latitudes many times, far too quickly to be accounted for by continental drift. There has also been much more research into the recent past, which has supported Hapgood's estimation that the North Pole was near Hudson Bay during the last ice age. New evidence suggests that the transition of the poles ended a mere 15,000 years ago, later followed by violent global superfloods. It then took many millennia for the world's climates to change and then stabilize, for the world to settle into its new position. So polar wandering is not some distant phenomenon, unrelated to human history. As modern humans have been around a few million years, our ancestors lived through many polar ages and experienced many pole shifts, whether they happened to live in cities or caves, whether they were hunter-gatherers or farmers. So the birth, or perhaps rebirth, of civilization in the Middle East and the valleys of Pakistan about 10,000 years ago, was a stone's throw away from the last pole shift. It wasn't some distant event, but the very birth of their age. They would have risen up in the shadow of the last pole shift, which would have dominated their histories and shaped their mythologies and belief systems, the most common view being of the cyclical nature of history and time. But where did these people live before they settled in Indo-Pakistan, Mesopotamia and Egypt? Were they forced to migrate from the temperate lands of Siberia, or even of West Antarctica, when they were moved nearer to the frigid poles? Recent archaeological discoveries in Siberia have completely changed the known history of this region, revealing that tribal peoples lived there through much of the last ice age, and suggesting that these tribes then migrated to warmer climes following the last pole shift. Were they also forced to migrate from lowlying plains and valleys that were inundated when the mighty Laurentide ice sheet melted away? Marine archaeologists have uncovered the remains of what appear to be the ruins of great cities on the seafloor, causing bitter arguments about whether they are man-made or just natural formations, with the jury still very much out. The history of sea level rise following the glacial meltdown shows that many of these mysterious ruins were last above water when the North Pole was still in Hudson Bay, so the builders of these structures lived in the last polar age, before being forced to migrate to higher ground or warmer climes and rebuild their lives from scratch, just as the stories of so many cultures recount as having happened. Every pole shift would have changed the position of the sun and stars. As viewed from the ground, it would displace the entire sky. People living on part of the Earth's surface move towards one of the polar zones would experience the sky changing its orientation and the circumpolar stars rising to greater prominence. The sun would take a new course, moving along a lower path across the sky. So polar wandering is also a cosmological phenomenon, the stuff of myth and religion. And like those distant memories of immense flooding, preserved since at least Sumerian times, experiences of the shifting heavens would be remembered and preserved in myth and fable, forming a collective memory found in the traditions of cultures all over the world. Human experience of this event would have been passed down, generation after generation. Frederick Clay showed in Le Déluge that the traditions of many ancient cultures may contain just such a memory, found right at the core of some of the most sacred mythological and religious traditions, including the Bible and other sacred texts. And human experience of the tumultuous effects of the last crust displacement, such as earthquakes, major climatic change and glacial meltdown, would also have been transmitted through time. The echoes of the shifting Earth may still reverberate in the lore of ages, transmitted unerringly through time. Indeed, time becomes immaterial, these myths gaining a semblance of immortality. As the arch-traditionalist Michael Hoffman too said, there's something inherently totalitarian in dismissing the vast body of folklore and mythology just because it is old and traditional. And it seems the old folks were right. The world does go through a cycle. Ages. Each age ended when the sky falls and the sun wanders from its path across the heavens. Kyle Bennett references 1 Cuvier, in Roserand Flemeth 1995 When the Sky Fell, Stoddard Publishing, Ontario, p. 37. 2 Albert Einstein, in Hapgood, Charles Hutchins 1958 Path of the Pole. Souvenir Press, London, foreword to first edition, p. XIII. 3 Charles Hapgood, Path of the Pole 4 White, J. 1980 Pole Shift, EARE Press, Virginia Beach. Subject related links Part 3 Fragments from 1877 The Geological Magazine or Monthly Journal of Geology Decade 2. Volume IV. April 1877 page 183184 Click to see larger image 3, February 21, 1877, Professor P. Martin Duncan, M.B., FRS, President, in the chair. The following communications were read. 1. On possible displacements of the Earth's axis of figure produced by elevations and depressions of her surface. By the Rev. J. F. Twisden, M.A., Professor of Mathematics in the Staff College. Communicated by John Evans, ESQ, FRS, FGS. The object of this paper is to discuss the question of the possibility of a displacement of the Earth's axis of figure under the conditions indicated in a question suggesting the possibility of a displacement of the axis of figure from the axis of rotation amounting to it 9 or 20 are put to mathematicians in a passage of the anniversary address delivered to the Geological Society by its president, J. Evans, ESQ, on the 18th of February 1876. The treatment of the question is kinematical. The forces by which the elevations and depressions might be affected do not come under discussion. In determining numerically the amount of the deviation from the formulas investigated, approximate numbers seem to be sufficiently exact for every useful purpose. The conclusions arrived at are as follows. 1. The displacement of the Earth's axis of figure from the axis of rotation that would be affected by the elevations and depressions suggested in the question above referred to, would be less than 10 feet of angle. 2. A displacement of as much as 20 degrees could be affected by the elevations and depressions of the kind suggested only if their heights and depths exceeded by many times the height of the highest mountains. 3. Under no circumstances could a displacement of it be affected by a transfer of matter of less amount than about a sixth part of the whole equatorial bulge. For even if a transfer of this quantity of matter were to take place, it need not produce any effect, or only a small effect, on the position of the axis of figure, e.g. if it took place in a way resembling that suggested in the question, it would produce a displacement amounting to but a small part of 20 degrees. 5. If, however, we suppose a deviation of the axis of figure from the axis of rotation amounting to as much as 20 degrees to have been by any means brought about, the effect would be to cause a sort of tidal motion in the ocean, the greatest height of which would tend to be about twice the depth of the ocean. The author suggests as probable that the effect of this tendency would be to cause the ocean to sweep over the continents in much the same way that a rising tide sweeps over a low bank on a level shore. 6. The notion that a large deviation of the Earth's axis of figure from its axis of revolution may be affected by elevations and accompanying depressions is at first sight an inviting way of bringing polar lands into lower latitudes, and thereby accounting for the more genial climate that is believed to have once prevailed in such countries as Greenland. The investigation by which the above results have been obtained seems to show that the desired explanation is not to be sought in the direction indicated by Miss Revant's question. Whether there is any other agency by which a gradual displacement of the pole geographically could be effected is a question of far wider scope than that discussed in the present paper, and one which the author does not profess to determine. Point 1 Discussion. Mr. Evans was willing to admit that in his address B had somewhat overstated the amount of change in the position of the polar axis which was likely to result from the supposed belts of elevation and depression. When, however, B was told that the displacement would not exceed 10 miles, notwithstanding his implicit faith in mathematics, there arose an inward feeling of disbelief as to the conditions of the problem having been accurately stated in order to obtain such a result. It seemed to him that the author bad treated the globe as an absolutely solid spheroid instead of a terraqueous globe, with the proportions of land and sea upon each surface ns at present existing, which were important elements in the case. The depth of the ocean in equatorial and ND polar regions ought surely to be taken into account, as it was quite possible to conceive of the irregularly shaped solid portion of the globe projecting in places through a spheroidal coating of water, so as to form large tracts of land, and yet on the average forming a sphere. Such a sphere, from disturbances of its equilibrium, he believed would be much more liable to changes in its axis than a spheroid, and the nearer a spheroid approached a sphere, the more sensible it would become to such disturbances. He had never intended to suggest that the hypothetical belt was to be suddenly elevated so as to produce the enormous tidal movements of which the author spoke. On the contrary, he believed that all such disturbances of equilibrium were gradual, and that the axis of rotation and that of figure were never at any great distance from each other. There was one portion of the paper which he found difficult to comprehend. He could not conceive why so enormous a protuberance as 125 miles over a belt 20 feet in width should be necessary in order to displace the polar axis by 20 degrees, when the present equatorial protuberance was only about 1/10 of that height. Moreover, the probability is that the Earth, instead of being a rigid solid, is to a certain extent viscous, a pfnstic, and that such should be the case seems quite in accordance with geological facts. If the globe were a viscous body, with a solid crust one, the first draft of the paper, of which the above tease an account, was drawn up last Alfrast, and when shortly after bent to Mr. Cavans. It was written independently of the wider view of the subject taken by Sir W. Thomson in his address delivered at the last meeting of the British Association, and by Mr. G. Darwin in his paper, of which an abstract has been published in number 176 of the Proceedings of the Royal Society. Of moderate thickness, elevations such as suggested in the address might well suffice to bring about a shifting of the crust, either by sliding on the fluid of viscous interior, or by causing it to undergo a certain amount of gradual deformation. The thinner the crust, provided it were sufficiently rigid to support the elevations once made upon it, the more readily would its geographical position be changed with regard to the poles. With regard to the thickness of the crust at the present time, he did not despair of astronomers at last conceding a less thickness than that assigned by the late Mr. Hopkins and Sir William Thomson. He was glad to find that the latter, in his address to the mathematical section of the British Association at Glasgow, was willing not merely to admit, but to assert as highly probable, that the axis of maximum inertia of the Earth and the axis of rotation, always very near one another, may have been in ancient times very far from their present geographical position, and may have gradually shifted through 10, 20, 30, 40, or more degrees, without at any time any perceptible sudden disturbance of either land or water. Mr. George Darwin, also no mean mathematician, in his paper recently communicated to the Royal Society, agrees as to the probability of large geological changes affecting the position of the poles, and regards the effect of such changes as possibly cumulative. Mr. Evans felt that the Society was much indebted to Mr. Twisden for having likewise investigated the question, in which, of course, he was personally much interested. Professor Ramsay referred to the former prevalence in geology of views which had long since been exploded, and expressed his opinion that before long the theory of the fixed geographical position of the poles of the Earth would share the same fate, and that the position of the poles would be regarded as very variable indeed. The flora of various deposits in polar lands indicated the growth of plants which would require the stimulus of light, even if the necessary amount of heat for their growth could be accounted for. With respect to great local changes of level, he remarked that the northern part of Africa was 4,000 feet below the level of the sea in very recent times, and there was considerable reason to suppose that even later than the Miocene a vast tract of land occupied the space between what were now the continents of Africa and India. Of course, no one supposed that the position of the poles had been changed by rapid upheavals of land, as we know that all geological changes of level have been slow and gradual, so the poles may have altered their position by a process as slow as that of evolution which has originated those species of animals and plants during the long series of geological time. Such questions as these were serious questions involving the results of much observation, and could not, he thought, be solved in the closet by any amount of geological work. Source: Google Books on a possible geological cause of changes in the position of the axis of the Earth's crust by Sir John Evans, February 28, 1866. Editor's note: this is a digital transcription Google of a paper presented by Evans to the Royal Society of Great Britain. I have changed the format and correcting the spelling mistakes and errors made by the transcription. I have highlighted in bold those sections that are most relevant to Evans' views of crust displacements as an explanation for long-term climatic change. Otherwise the paper is exactly the same as the original. Kyle Bennett: at a time when the causes which have led to climatal changes in various parts of the globe are the subject of so much discussion, but little apology is needed for calling the attention of this society to what possibly may have been one of these causes, though it has apparently hitherto escaped observation. That great changes of climate have taken place, at all events in the northern hemisphere of the globe, is one of the best established facts of geology, and that corresponding changes have not been noticed to the same extent in the southern hemisphere may possibly be considered as due, rather to a more limited amount of geological observation, than to an absence of the phenomena indicative of such alterations in climatal conditions having occurred. The evidence of the extreme refrigeration of this portion of the Earth at the glacial period is constantly receiving fresh corroboration, and various theories have been proposed which account for this accession of cold in a more or less satisfactory manner. Variations in the distribution of land and water, changes in the direction of the Gulf Stream, the greater or less eccentricity of the Earth's orbit, the passage of the solar system through a cold region in space, fluctuations in the amount of heat radiated by the sun, alternations of heat and cold in the northern and southern hemispheres, as consequent upon the precession of the equinoxes, and even changes in the position of the center of gravity of the Earth and consequent displacements of the polar axis, have all been adduced as causes calculated to produce the effects observed, and the reasoning founded on each of these data is no doubt familiar to all. The possibility of any material change in the axis of rotation of the Earth has been so distinctly denied by Laplace and all succeeding astronomers, that any theory involving such a change, however tempting as affording a solution of certain difficulties, has been rejected by nearly all geologists as untenable. Sir Henry James, however, writing to the Athenaeum newspaper in 1861, stated that he had long since arrived at the conclusion that there was no possible explanation of some of the geological phenomena testifying to the climate at certain spots having greatly varied at different periods, without the supposition of constant changes in the position of the axis of the Earth's rotation. He then, were assuming as an admitted fact that the Earth is at present a fluid mass with a hardened crust, showed that slaty cleavage, dislocations, and undulations in the various strata are results which might be expected from the crust of the Earth having to assume a new external form, if caused to revolve on a new axis, and advanced the theory that the elevation of mountain chains of larger extent than at present known produced these changes in the position of the poles. The subject was discussed in further letters from Sir Henry James, the Astronomer Royal, Professors Beat, Jukes and Hennessy, and others, but throughout the discussion the principal question at issue seems to have been whether any elevation of a mountain mass could sensibly affect the position of the axis of rotation of the globe as a whole, and the general verdict was in the negative. At an earlier period, 1848, the late Sir John Lubbock, in a short but conclusive paper in the Quarterly Journal of the Geological Society, pointed out what would have been the effect had the axis of rotation of the Earth not originally corresponded with the axis of figure, and also mentioned some considerations which appear to have been absent from Laplace's calculations. Sir John Lubbock, however, in common with other astronomers, appears to have regarded the Earth as consisting of a solid nucleus with a body of water distributed over a portion of its surface, and there can be but little doubt that, on this assumption of the solidity of the Earth, the usually received doctrines as to the general persistence of the direction of the poles are almost unassailable. Directly, however, that we argue from the contrary assumption that the solid portion of the globe consists of a comparatively thin, but to some extent rigid crust with a fluid nucleus of incandescent mineral matter within, and that this crust, from various causes, is liable to changes disturbing its equilibrium, it becomes apparent that such disturbances may lead, if not to a change in the position of the general axis of the globe, yet at all events to a change in the relative positions of the solid crust and the fluid nucleus, and in consequence to a change in the axis of rotation, so far as the former is concerned. The existence in the center of the globe of a mass of matter fluid by heat, though accepted as a fact by many, if not most geologists, has no doubt been called in question by some, and among them a few of great eminence. The gradual increase of temperature, however, which is found to take place as we descend beneath the surface of the Earth, and which has been observed in mines and deep borings all over the world, the existence of hot springs, some of the temperature of boiling water, and the traces of volcanic action, either extinct or still in operation, which occur in all parts of the globe, afford strong arguments in favor of the hypothesis of central heat. And though we are at present unacquainted with the exact law of the increment of heat at different depths, and though, no doubt, under enormous pressure the temperature of the fusing point of all substances may be considerably raised, yet the fact of the heat increasing with the depth from the surface seems so well established that it is highly probable that at a certain depth such a degree of heat must be attained as would reduce all mineral matter with which we are acquainted into a state of fusion. When once this point was attained, it seems probable that there would be no very great variation in the temperature of the internal mass, but whether the whole is in one uniform state of fluidity, or whether there is a mass of solid matter in the center of the fluid nucleus, are questions which do not affect the hypothesis about to be considered. Those who are inclined to regard the Earth as a solid or nearly solid mass throughout, consider that many volcanic phenomena may be accounted for on the chemical theory, which has received the support, among others, of Sir Charles Lyell. But apart from the consideration that such chemical action must of necessity be limited in its duration, the existence of local seas of fluid matter, resulting from the heat generated by intense chemical action, would hardly account for the increase of heat at great depths in places remote from volcanic centers, and the rapid transmission of shocks of earthquakes, and the enormous amount of upheaval and subsidence as evidenced by the thickness of the sedimentary strata, seem inconsistent either with the general solidity of the globe or any very great thickness of its crust. The supposition that the gradual oscillations of the surface of the Earth, of which we have evidence all over the world as having taken place ever since the formation of the earliest known strata up to the present time, are due to the alternate inflation by gas and the subsequent depletion of certain vast bladdery cavities in the crust of the Earth, can hardly be generally accepted. Those who wish to see the arguments for and against the theory of there being a fluid nucleus within the Earth's crust, will find them well and fairly stated in Naumann's Lehrbücher der Geognosie. My object is, not to discuss that question, but to point out what, were assuming the theory to be true, would be some of the effects resulting from such a condition of things, more especially as affecting climatal changes. The agreement or disagreement between these hypothetical results and observed facts may ultimately assist in testing the truth of the assumption. The simplest form in which we can conceive of the relations to each other of a solid crust and a fluid nucleus in rotation together is that of a sphere. Let a CBD be a hollow sphere composed of solid materials and of perfectly uniform thickness and density, and let it be filled with a fluid matter E, over which the solid shell can freely move, and let the whole be in uniform rotation about an axis FG, the line CD representing the equator. It is evident that in such a case, the hollow sphere being in perfect equilibrium, its axis and that of its fluid contents would perpetually coincide. If, however, the equilibrium of the shell or crust be destroyed, as, for instance, by the addition of a mass of extraneous matter at h, midway between the pole and the equator, not only would the position of the axis of rotation be slightly affected by the alteration in the position of the center of gravity of the now irregular sphere, but the centrifugal force of the excess of matter at h would gradually draw over the shell towards d until, by sliding over the nucleus, it attained its greatest possible distance from the center of revolution by arriving at the equator. The resultant effect would be that though the whole sphere continued to revolve around an axis as nearly as possible in the line FG, yet the position of the pole of the hollow shell would have been changed by 45 degrees, as by the passage of H to the equator the points I and K would have been brought to the poles by spirals constantly decreasing in diameter, while A and B, by spirals constantly increasing, would have at last come to describe circles midway between the poles and the equator. The axis of rotation of the hollow sphere and that of its fluid contents would now again coincide, and would continue to do so perpetually unless some fresh disturbance in the equilibrium of the shell took place. If instead of the addition of fresh matter at H we had supposed an excavation or removal of some portion of the shell, a movement in the axis of rotation of the shell would also have ensued, since from the diminished centrifugal force of that portion of the hollow sphere where the excavation had taken place, it would no longer equipoise the corresponding portion on the opposite side at A, and the excavated spot would eventually find its way to the pole. In order more clearly to exhibit these effects, I have prepared a model in accordance with a suggestion of Mr. Francis Galton, FRS, in which a wheel representing a section of a hollow sphere has its axis, upon which it can freely turn, fixed in a frame, which is itself made to revolve in such a manner that the axis of its rotation passes through one of the diameters of the wheel, and coincides with what would be the axis of the sphere of which the wheel is a section. In the periphery of the wheel are a number of adjustable screws with heavy heads, so that, by screwing any of them in or out, the addition of matter or its subtraction at any part of the sphere may be represented. If by adjusting these screws the wheel could be brought into perfect equilibrium, its position upon its own axis would remain unchanged in whatever position it was originally placed, notwithstanding any amount of rotation being given to the frame in which it is hung. But practically it is found that with a certain given position of the screws a certain part of the wheel coincides with the axis of the frame, or becomes the pole around which the sphere revolves. The rim of the wheel is graduated so as to show the position of the poles in all cases, and generally speaking the wheel always settles down after rotation with the pole within 3 or 4 degrees of the same spot, if no alteration has been made in the adjustment of the screws, though of course what was the uppermost pole may become the lower one, and in some cases the wheel may be in equilibrium with a projecting screw either above or below the equator, in which case there may be 4 unreadable on the circle at the index point, according as the one pole or the other is uppermost, and the projecting screw is above or below the equator. With the screws on the wheel evenly balanced, a slight alteration in the adjustment of any of them immediately tells upon the position of what, for convenience sake, may be called the poles, except, indeed, in such cases as screwing outward sows already at the equator, or making similar alterations in the adjustment of 2 screws at equal distances on either side of one of the poles. If a screw be turned outward so as notably to project at any spot, no matter how near to the pole, it will be found, after the machine has been a short time in revolution, in the region of the equator. Or again, if one or, better still, 2 opposite screws at the equator be turned inwards, they will be found after a short period of revolution at the poles. Now let us assume for a moment that, though the crust was partially covered by water, the Earth, instead of being a spheroid, was a perfect sphere, consisting of a hardened crust of moderate thickness supported on a fluid nucleus over which the crust could travel freely in any direction, but both impressed with the same original rotatory motion, so that without some disturbing cause they would continue to revolve forever upon the same axis, and as if they were one homogeneous body. Let us assume, moreover, that this crust, though in perfect equilibrium on its center of rotation, was not evenly spherical externally, but had certain projecting portions, such as would be represented in nature by continents and islands rising above the level of the sea. It is evident that so long as those continents and islands remained unaltered in their condition and extent, the relative position of the crust to the enclosed fluid nucleus would remain unaltered also. But supposing those projecting masses were either further upheaved from some internal cause, or worn down and ground away by the sea or by subaerial agency and deposited elsewhere, it seems impossible but that the same effects must ensue as we see resulting upon the model from the elevation and depression of certain screws, and that the axis of rotation of the crust of the sphere would be changed in consequence of its having assumed a fresh position upon its fluid nucleus, though the axis of the whole sphere might have retained its original direction, or have altered from it only in the slightest degree. An irregular accumulation of ice at one or both of the poles, such as supposed by M. Adhemar, would act in the same manner as an elevation of the land, and even assuming that the whole land had disappeared from above the surface of the sea. Yet if by marine currents the shallower parts of the universal ocean were deepened and the deeper parts filled up, there would, owing to the different specific density of the transported soil and the displaced water, be a disturbance in the equilibrium of the crust, and a consequent change in the position of its axis of rotation. Now if all this be true of a sphere, it will also, subject to certain modifications, be true of a spheroid so slightly oblate as our globe. The main difference in the two cases is, that in a sphere the crust may assume any position upon the nucleus without any alteration in its structure, while in the case of the movement of a spheroidal crust over a similar spheroidal nucleus, every portion of its internal structure must be more or less disturbed, as the curvature at each point will be slightly altered. The extent of the resistance to an alteration of position arising from this cause will depend upon the oblateness of the spheroid and the thickness and rigidity of the crust, while the thicker the latter is, the less also will be the proportionate effect of such elevations, subsidences, and denudations as those with which we are acquainted. The question of friction upon the nucleus is also one that would have to be considered, as the internal matter, though fluid, might be viscous. It will of course be borne in mind that the elevations and depressions of the surface of the globe are not, on the theory now under consideration, regarded according to the proportion they bear to the Earth's radius, but according to their relation to the thickness of the Earth's crust, and that, even assuming Mr. Hopkins' extreme estimate to be true, yet elevations or depressions, such as we know to have taken place, of 8,000 to 10,000 feet, bear an appreciable ratio to the 800 or 1,000 miles which he assigns as the thickness of the Earth's crust. It is, however, to be remarked that the extremely ingenious speculations of Mr. Hopkins are based on the phenomena of precession and nutation, and that if once the possibility of a change in the position of the axis of rotation of the Earth's crust be admitted, it is not improbable that the value of some of the data upon which the calculations of these movements are founded may be affected. The supposition of the thickness of the crust being so great seems also not only entirely at variance with observed facts as to the increase of heat on descending beneath the surface of the Earth, but to have been felt by Mr. Hopkins himself to offer such obstacles to any communication between the surface of the globe and its interior, that he has had recourse to an hypothesis of large spaces in the crust at no great depth from the surface and filled with easily fusible materials, in order to account for volcanic and other phenomena. But though it may be possible to account for volcanoes upon such an assumption, yet, as already observed, the phenomena of elevation and depression, such as we find to have taken place, and more especially the existence of vast geological faults, cannot without enormous difficulty be reconciled with such a theory. Taking the increment of heat as 1 degree Fahrenheit for every 55 or 60 feet in descent, a temperature of 2,400 degrees Fahrenheit would be reached at about 25 miles, sufficient to keep in fusion such rocks as basalt, greenstone, and porphyry, and such a thickness appears much more consistent with the fluctuations in level, and the internal contortions and fractures of the crust which are everywhere to be observed. Sir William Armstrong, on the assumption of the temperature of subterranean fusion being 3,000 degrees Fahrenheit, considers that the thickness of the film which separates us from the fiery ocean beneath would be about 34 miles. Even assuming a thickness of 50 miles, so as to make still greater allowance for the increased difficulty of fusion under heavy pressure, the thickness of the crust would only form only 80th part of the radius of the Earth, or if we represent the Earth by a globe 13 feet in diameter, the crust would be 1 inch in thickness, while the difference between the polar and equatorial diameters would be half an inch. In such a case, the elevation or wearing away of continents such as are at present in existence, rising, as some of them do, nearly a quarter of a mile on an average above the mean sea level, would cause a great disturbance in the equilibrium of the crust, sufficient to overcome considerable resistance in its attempts to regain a state of equilibrium by a movement over its fluid nucleus. whether the thickness of the Earth's crust was not in early geological times less than at present, so as to render it more susceptible of alterations in position, whether the spheroid of the fluid mineral nucleus corresponds in form with the spheroid of water which gives the general contour of the globe, whether or not there are elevations and depressions upon the nucleus corresponding to some extent with the configuration of the outer crust, and whether the motion of the crust upon it, besides affecting climatal changes, might not also lead to some elevations and depressions of the land, and produce some of the other phenomena mentioned by Sir Henry James, are questions which I will leave for others to discuss. My object is simply to call attention to what appears to me the fact, that if, as there seems reason to suppose, our globe consists of a solid crust of no great thickness resting on a fluid nucleus, either with or without a solid central core, and if this crust, as there is abundant evidence to prove, is liable to great disturbances in its equilibrium, then it of necessity follows that changes take place in the position of the crust with regard to the nucleus, and an alteration in the position of the axis of rotation, so far as the surface of the Earth is concerned, ensues. Without in the slightest degree undervaluing other causes which may lead to climatal changes, I think that possibly we may have here a vera causa such as would account for extreme variations from a tropical to an Arctic temperature at the same spot, in a simpler and more satisfactory manner than any other hypothesis. The former existence of cold in what are now warm latitudes might, and probably did in part, arise from other causes than a change in the axis of rotation, but no other hypothesis can well account for the existence of traces of an almost tropical vegetation within the Arctic Circle. Of the former existence of such a vegetation, the evidence, though strong, is not conclusive. But if the fossil plants of Melville Island, at 75 degrees north latitude, which appear to agree generically with those from the English coal measures, readily grew upon the spot where they were now discovered, they seem to afford conclusive evidence of a change in the position of the pole since the period at which they grew, as such vegetation must be considered impossible in so high a latitude. The Cons and orthoceratites from Griffiths Island and Cornwallis Island, and the Liassic ammonites from Point Wilkie, Prince Patrick's Island, tell the same story of the former existence of something like a subtropical climate at places at present well within the Arctic Circle. To use the words of the Rev. Samuel Horton, in describing the fossils collected by Sir F. L. M. Cleartock, the discovery of such fossils in situ, in 70 north latitude, is calculated to throw considerable doubt upon the theories of climate which would account for all past changes of temperature by changes in the relative position of land and water on the Earth's surface, and I think that all geologists will agree with this remark, and feel that if the possibility of a change in the position of the axis of rotation of the crust of the Earth were once admitted, it would smooth over many difficulties they now encounter. That some such change is indeed taking place at the present moment may not unreasonably be inferred from the observations of the Astronomer Royal, who, in his report to the Board of Visitors for 1861, makes use of the following language, though only for the sake of embodying his description of the observed facts, as he refers the discrepancies noticed to some peculiarity of the instruments. The transit circle and collimators still present those appearances of agreement between themselves and of change with respect to the stars which seem explicable only on one of two suppositions, that the ground itself shifts with respect to the general Earth, or that the axis of rotation changes its position. 1 Athenium newspaper M6c. C61, Volume V. P. 14. T. Athenium, August 26, 1862. Naumann's Lehrbuch der Geognosie, 2nd edit, IMS, Volume I. P. 36. About crustal displacement. The theory of crustal displacement states that the entire crust of the Earth can shift in one piece like the loose skin on an orange. By studying the carcasses of the woolly mammoth and rhino found in the northern regions of Siberia and Canada, one can see the land these animals gazed on was suddenly shoved into a much colder climate. Their stomachs reveal food found in warm climates where they grazed just prior to their deaths. This was found frozen along with them suddenly. Thousands of animals were found to be frozen in a brief moment of geological time. Ancient maps of Antarctica suggest that it too was frozen over in a brief moment in time. It has been suggested that approximately 12,000 years ago there was a displacement of the Earth's crust. The entire outer shell of the Earth moved approximately 2,000 miles. When the Earth's crust shifted, all of Antarctica was encapsulated by the polar zone. At the same time, North America was released from the Arctic Circle and became temperate. This is based on the theory of continental drift, Earth's continents slowly drifting apart over millions of years. This is possible because the outer crust of the Earth floats upon a semi-liquid layer. A pole shift theory is a hypothesis based on geologic evidence that the physical north and south poles of Earth have not always been at their present-day locations. In other words, the axis of rotation had shifted. Pole shift theory is almost always discussed in the context of Earth, but other solar system bodies may have experienced axial reorientation during their existences. For example, Venus and Jupiter have a very small axial tilt, 3 degrees versus Earth's 23.5 degrees, while the axis of Uranus is tilted by 98 degrees. Charles Hapgood, The Earth's Shifting Crust. In 1958, Hapgood published The Earth's Shifting Crust, which denied the existence of continental drift and featured a foreword by Albert Einstein. In Maps of the Ancient Sea Kings 1966 and The Path of the Pole 1970, Hapgood proposed the hypothesis that the Earth's axis has shifted numerous times during geological history. In Maps of the Ancient Sea Kings he supported the suggestion made by Arlington Mallory that a part of the Piri-Reis map was a depiction of the area of Antarctica known as Queen Maud Land. He used this to propose that a 15-degree pole shift occurred around 9600 BCE, approximately 11,600 years ago, and that a part of the Antarctic was ice-free at that time, and that an Ice Age civilization could have mapped the coast. He concludes that Antarctica was mapped when these parts were free of ice, taking that view that an Antarctic warm period coincided with the last ice age in the northern hemisphere, and that the Piri-Reis and other maps were based on ancient maps derived from Ice Age originals. Later research concerning the paleoclimatology and ice sheets of Antarctica have completely discredited the interpretations by Hapgood that an Antarctic warm period coincided with the last ice age in the northern hemisphere, and any part of it had been ice-free at and prior to 9600 BCE, approximately 11,600 years ago. Hapgood also examined a 1531 map by French mathematician and cartographer Oronce Phinéas aka Orontius Phineas. In Maps of the Ancient Sea Kings, he reproduces letters received from the chief of a U.S. Air Force cartography section stationed at Westover AFB in 1961. At Hapgood's request, they had studied both Piri-Reis and Oronce Phinéas maps during their off-duty hours, concluding that both were compiled from original source maps of Antarctica at a time when it was relatively free of ice, supporting Hapgood's findings. Hapgood concluded that advanced cartographic knowledge appears on the Piri-Reis map and the Orontius Phineas map, and must be the result of some unknown and advanced ancient civilization that developed astronomy, navigational instruments, plane geometry and trigonometry, long before Greece or any other known civilization. According to historians Paul Hoy and Paul Luna, while Hapgood's work garnered some enthusiasm and praise for its thoroughness, his revolutionary hypotheses largely met with skepticism and were ignored by most scholars. In the book The Piri-Reis Map of 1513, Gregory C. McIntosh examines Hapgood's claims for both maps and states that they fall short of proving or even strongly suggesting that the Piri-Reis map and the Fine map depict the actual outline of Antarctica. Hapgood's unorthodox interpretations such as Earth crustal displacement were never accepted as valid competing scientific hypotheses, yet his ideas have found popularity in alternative circles. Librarians Rand and Rose Flemeth as well as journalist Graham Hancock base portions of their works on Hapgood's evidence for catastrophe at the end of the last glacial maximum. The prehistoric alignment of world wonders Easter Island is exactly aligned along a straight line around the center of the Earth, with the Nazca Lines, Ollantaytambo and the Great Pyramid of Egypt. Other world wonders that are within 1/10 of 1 degree of this alignment include Persepolis, the capital city of ancient Persia Mohenjo-Daro, the ancient capital city of the Indus Valley, the Oracle of Zeus'Amun at Shiva and the lost city of Petra. The ancient Sumerian city of Ur and Angkor temples in Cambodia and Thailand are within 1 degree of latitude of this alignment. The alignment of these sites is easily observable on a globe of the Earth with a horizon ring. If you line up any two of these sites on the horizon ring, all of the sites will be right on the horizon ring. The two axis points for the Great Circle are located at 59 degrees 53 north latitude and 138 degrees 36 west longitude, and at 59 degrees 53 south latitude and 41 degrees 24 east longitude. The southern axis point is in deep water approximately 500 miles from the coast of Antarctica. The northern axis point is in the northwestern corner of Canadian British Columbia on a glaciated ridge line approximately 6,500 feet above sea level. Source: The Prehistoric Alignment of World Wonders. P.S. Can an earthquake shift the Earth's axis? The short answer to this is yes. But the effects of such a shift are tiny. The Earth's tilt and rotational spin on its axis as it travels around the Sun causes our seasons. The earthquake in Japan moved the axis of rotation by around 16 centimeters. That might sound like a lot, but it's small compared to the size of the Earth. 1 degree change to the tilt of the axis of the Earth would mean moving it by around 110 kilometers. But the quake's interference with our axis doesn't stop there. The Japanese landmass was moved around by as much as 4 meters. This redistribution of mass on the surface changes our moment of inertia. In order to conserve angular momentum, the changes in inertia are compensated by changes in the rate of rotation of the Earth about the axis. After the earthquake, it's quite possible that our days will be 1.8 millionths of a second shorter because of this shifting. We can see differences in the average length of the day due to other changes in the Earth and atmosphere. The plots below show that there is a significant seasonal variation, with the day length speed of rotation being fastest during the boreal summer. This happens because the northern hemisphere winds slow down in the summer and the momentum they lose, half the momentum of the atmosphere, is transferred to the Earth. This increase in momentum makes the Earth spin faster and our days become slightly shorter by 12 milliseconds. So while the changes brought to our planet by the earthquake are unique and colossal enough to affect the Earth, they aren't big enough that we will notice them any more than we notice the milliseconds we lose each summer. Source: http www.bbc.co.uk blogs 23 degrees 201103 can _an_earthquake _shift_ the_air.html